The next tool in our toolbox is the powerful local keyword. This allows us to nest a bunch of definitions inside of an expression. Let's make a simple example by writing a function that swaps a string's first half and second half. So we'll write midswap, consumes a string and produces a string. Then this is a function that consumes a string and produces a new string with the first half moved after the second half. Define midswap, consumes a string, and ... Let's write our checky specs, as we always do. Midswap consumes a string catdog and produces a string dogcat. For something more exotic, we'll pick a odd number of letters, and this will be corgi, produces a string argico. Alright, let's actually implement this function. So we're going to use our local keyword. The format of this is a series of clauses followed by one last expression, as we can see up here. So our first clause is going to be a define inside of this other definition. This is a whole new area, a whole new way of life. So we use the define keyword to define a new constant called length. It is equal to the value of string length stir, so this gets the length of the string and assigns it to length. This is kind of similar to the idea of temporary variables in other programming languages, which you might be familiar with. So now we'll also do another one for midpoint. That's rounding the length divided by 2 of the string. So let's get that straight. So we divide the length by 2 and round in the right direction. We'll define another one called first half, substring the string from 0 to the midpoint. And then we'll define one last called the last half, substringing the string from the midpoint to the end. So we have 4 definitions inside of our function definition here. They only are useful for the duration of this function. Once they're done, they're gone. They don't escape. So length can never be used outside of this function definition. But that's okay. It's all we need it for. Because then we can just go ahead and write our last expression, and that's just the last half plus the first half. A very straightforward application of the definitions we made before. We got the length of the string, we found the midpoint, we found the first half, we found the last half. Each one in its own neat, orderly line. And then the last expression here, the string append, is the thing actually returned by the function. So you can put any number of definitions up here, and only the last one actually gets returned. The local expression allowed us to name individual steps of the execution in a really elegant way, simplifying the code we had to use. We saw that it let us write some clean code, but it also can speed up computation by avoiding repeated computations. Remember, each time you call a function, it takes some amount of time. And if a function takes a long time, and you have to call it twice, then you're paying a pretty big cost. What if we knew that finding the length of a string was a very time-consuming function? Say it took like 10 seconds on a long string, like the text of all the books in the library. Well, we only had to call the string length once because we saved its value in the length variable. And then we could use that twice instead. Instead of having to call the function twice, we just use the variable, which was much faster. These savings can be huge in practice for big strings and lists and files.